Truth and consequences. Speed is a measure of how far an object can travel in a given duration of time. If we are in a car going 65 miles per hour, this means of course that we will travel 65 miles if we persist in this state of motion for an hour. Phrased in this manner, speed is a rather mundane concept, and you may wonder about the fuss we have made regarding the speed of baseballs, snowballs, and photons. However, let's note that distance is a notion about space. In particular, it is a measure of how much space there is between 2 points. Also note that duration is a notion about time, how much time elapses between 2 events. Speed, therefore, is intimately connected with our notions of space and time. When we phrase it this way, we see that any experimental fact that defies our common conception about speed, such as the constancy of the speed of light, has the potential to defy our common conceptions of space and time themselves. It is for this reason that the strange fact about the speed of light deserves detailed scrutiny given to it by Einstein, leading him to remarkable conclusions. The effect on time, Part 1. With minimal effort, we can make use of the constancy of the speed of light to show that the familiar everyday conception of time is plain wrong. Imagine that the leaders of 2 warring nations, sitting at opposite ends of a long negotiating table, have just agreed to a ceasefire, but neither wants to sign the accord before the other. The Secretary-General of the United Nations comes up with a brilliant resolution. A light bulb, initially turned off, will be placed midway between the 2 presidents. When it is turned on, the light it emits will reach each of the presidents simultaneously, since they are equidistant from the bulb. Each president agrees to sign a copy of the accord when he or she sees the light. The plan is carried out and the agreement is signed to the satisfaction of both sides. Flushed with success, the Secretary-General makes use of the same approach with 2 other embattled nations that have also reached a peace agreement. The only difference is that the presidents involved in this negotiation are sitting at opposite ends of a table inside a train traveling along at constant velocity. Fittingly, the president of forwardland is facing in the direction of the train's motion while the president of backwardland is facing in the opposite direction. Familiar with the fact that the laws of physics take precisely the same form regardless of one's state of motion so long as this motion is unchanging, the Secretary-General takes no heed of this difference and carries out the light bulb-initiated signing ceremony as before. Both presidents sign the agreement and, along with their entourage of advisors, celebrate the end of hostilities. Just then, word arrives that fighting has broken out between people from each country who had been watching the signing ceremony from the platform outside the moving train. All those on the negotiation train are dismayed to hear that the reason for the renewed hostilities is the claim by people from forwardland that they have been duped, as their president signed the agreement before the president of backwardland. As everyone on the train, from both sides, agrees that the accord was signed simultaneously, how can it be that the outside observers watching the ceremony think otherwise? Let's consider in more detail the perspective of an observer on the platform. Initially, the bulb on the train is dark, and then at a particular moment it illuminates, sending beams of light speeding toward both presidents. From the perspective of a person on the platform, the president of forwardland is heading toward the emitted light while the president of backwardland is retreating. This means, to the platform observers, that the light beam does not have to travel as far to reach the president of forwardland, who moves toward the approaching light, as it does to reach the president of backwardland, who moves away from it. This is not a statement about the speed of the light as it travels toward the 2 presidents. We have already noted that regardless of the state of motion of the source or the observer, the speed of light is always the same. Instead, we are describing only how far, from the vantage point of the platform observers, the initial flash of light must travel to reach each of the presidents. Since this distance is less for the president of forwardland than it is for the president of backwardland, and since the speed of light toward each is the same, the light will reach the president of forwardland first. This is why the citizens of forwardland claim to have been duped. When CNN broadcasts the eyewitness account, the Secretary-General, the 2 presidents, and all of their advisors can't believe their ears. They all agree that the light bulb was secured firmly, exactly midway between the 2 presidents, and that therefore, without further ado, the light it emitted traveled the same distance to reach each of them. Since the speed of the emitted light to the left and to the right is the same, they believe, and in fact observed, that the light clearly reached each president simultaneously. Who is right, those on or off the train? The observations of each group and their supporting explanations are impeccable. The answer is that both are right. Like our two space inhabitants George and Gracie, each perspective has an equal claim on truth. The only subtlety here is that the respective truths seem to be contradictory. An important political issue is at stake. Did the president sign the agreement simultaneously? The observations and reasoning above ineluctably lead us to the conclusion that according to those on the train they did, while according to those on the platform they did not. In other words, things that are simultaneous from the viewpoint of some observers will not be simultaneous from the viewpoint of others if the two groups are in relative motion. This is a startling conclusion. It is one of the deepest insights into the nature of reality ever discovered. Nevertheless, if long after you set down this book you remember nothing of this chapter except for the ill-fated attempt at détente, you will have retained the essence of Einstein's discovery. Without highbrow mathematics or a convoluted chain of logic, this completely unexpected feature of time follows directly from the constancy of the speed of light, as the scenario illustrates. Notice that if the speed of light were not constant but behaved according to our intuition based on slow-moving baseballs and snowballs, the platform observers would agree with those on the train. A platform observer would still claim that the photons have to travel farther to reach the president of backwardland than they do to reach the president of forwardland. However, usual intuition implies that the light approaching the president of backwardland would be moving more quickly, having received a kick from the forward-moving train. Similarly, these observers would see that the light approaching the president of forwardland would be moving more slowly, being dragged back by the train's motion. When these erroneous effects were considered, the observers on the platform would see that the light beams reached each president simultaneously. However, in the real world light does not speed up or slow down, it cannot be kicked to a higher speed or dragged to a slower one. Platform observers will therefore justifiably claim that the light reached the president of forwardland first. The constancy of the speed of light requires that we give up the age-old notion that simultaneity is a universal concept that everyone, regardless of their state of motion, agrees upon. The universal clock previously envisioned to dispassionately tick off identical seconds here on Earth and on Mars and on Jupiter and in the Andromeda galaxy and in each and every nook and cranny of the cosmos does not exist. On the contrary, observers in relative motion will not agree on which events occur at the same time. Once again, the reason that this conclusion, a bona fide characteristic of the world we inhabit, is so unfamiliar is that the effects are extremely small when the speeds involved are those commonly encountered in everyday experience. If the negotiating table were 100 feet long and the train were moving at 10 miles per hour, platform observers would see that the light reached the president of forwardland about a millionth of a billionth of a second before it reached the president of backwardland. Although this represents a genuine difference, it is so tiny that it cannot be detected directly by human senses. If the train were moving considerably faster, say at 600 million miles per hour, from the perspective of someone on the platform the light would take almost 20 times as long to reach the president of backwardland compared with the time to reach the president of forwardland. At high speeds, the startling effects of special relativity become increasingly pronounced.